In this video, I will show how to optimize certain functions when working with profit, revenue, and cost functions. First, let's see what's given. We have a price function, which determines the price at which Q units of a particular commodity can be sold, and we have a total cost function. So to find the revenue function, we have to multiply the price function by the quantity. So the revenue will be simply price times quantity. So it is 37Q minus 2Q squared. Immediately we can find the profit function. Profit function is just revenue minus cost. So it's 37Q minus 2Q squared minus cost, which is minus 3Q squared minus 5Q minus 75, which can be simplified. So we have 32Q minus 5Q squared minus 75. Now we can find the marginal revenue function, which is simply the derivative of the revenue function, meaning it is 37 minus 4Q. And we can find the marginal cost function, which is derivative of the cost function, which is 6Q plus 5. And we found all the functions in part A. Now, in part B, we ask to maximize the profit function, and here we can use the criteria for maximizing the profit that economists use, or we can just use the calculus and find the derivative of the profit function, which is 32 minus 10Q, set it equal to 0 to find the critical value, which will be 3.2. And using the sign chart now, we can figure out the behavior of the original profit function. So when Q is greater than 3.2, the derivative will be less than 0, and when quantity is less than 3.2, the derivative will be positive, meaning the profit on the interval from 0 to 3.2 will be increasing, and on the right of it, it will be decreasing. Therefore, at 3.2, we have a relative. In this case, it is also the absolute maximum. So at which production level the profit is maximized? The answer is when we produce 3.2 units of the commodity. In part C, we have to find the average cost function, which is simply the total cost divided by Q. So the average cost function will be 3Q plus 5 plus 75 over Q. And to determine the level of production Q at which A of Q is minimized, we again can use the criterion for minimizing the average cost that economists use, or we can just use the principle that we learn in calculus. That is, to find the minimum of this function, we're going to find the derivative of this function, which is 3 minus 75Q squared, set it equal to 0, or find where the derivative does not exist. And before we do that, let's simplify this expression. So we have 3Q squared minus 75 over q squared, which can be also written as 3q minus 5q plus 5 divided by q squared. So looking at the sign chart, of the derivative of the average function, we can figure out the behavior of the average cost function. So we have actually three critical points, -5, 0, and 5. And at 0, multiplicity is even, so it's not going to change the sign. And since the leading coefficient is positive, the sign of the derivative of the average cost function will be positive on the very right, and then it will change the sign, then it will keep the sign, and then it will change the sign again. So that means the average cost function increases there, decreases there, decreases from 0 to 5, increases from 5 to infinity. Now, since we only considering q's that are greater or equal to 0, we have a restricted domain from 0 to infinity, so we only care about the behavior of the function on that interval. And what we see here is that at 5 we have local minimum, but in this case it is also the absolute minimum on the interval from 0 to infinity. So to answer the question at which level of production q the average cost is minimized, the answer is at q equals 5, the average cost is minimized.